Welcome to my kcse revision channel, Marita James, Kilwars Boys High School. Kindly subscribe my channel, click the notification bell, you get notified once I upload a new video. Today we are looking at mathematics, the area of a curve. And we have a question here. In the figure below, the shaded region is bounded by the line y is equals to 3x, y is equals to x, and the curve y is equals to 8x minus x squared. The two straight lines intersect the curve at point P and Q. So this is a curve y is equals to 8 minus x squared. Then we have this is a line y is equals to 3x, and this is a line y is equals to x. So the line, the curve, and the line they intersect at point P, y is equals to x, and the curve they intersect at point Q. So calculate the coordinates of P and Q. Calculate the coordinates of P and Q. So in the coordinates of P, we are using the equation y is equals to 3x, and the curve y is equals to 8x minus x squared. Because where there is an intersection of the curve and the line, the equation of 3x is equals to be 8x minus x squared. So you can have 3x, we have this one as 3x is equals to be 8x minus x squared. Because at the intersecting points, the 2 points are equal at the intersection point. So from here you can simply simplify and find the value of x. So you have collecting the like terms together, you can have 3x minus 8x minus plus of course x squared. This one is equals to, we have this one as equals to 0. So we have this as minus 5x plus now x squared is equivalent to 0. We can have this as x squared, which is equals to be 5x. So you factor out, so you can have x 5x. So we have this is, we can subtract, this is minus here, minus x squared minus 5. This one is equals to 0. So we have x into x minus 5 is equals to 0. So we have this is x is equals to 0, or x is equivalent to 5. So at this point, we know x is equals to 0 because point P is above the x, the values are above 0. So if you have these points are above 0, so we can now find the y is equals to be 3 into the value of x, 5, which is equals to p 15. The coordinates of p will be x is equals to 5, y is equals to 15. Now we proceed and find the coordinates of q. We can find the coordinates of q. The coordinates of q, a line y is equals to x and the curve. So the coordinates of q, we are using the line y is equals to x, and the curve y is equals to be 8 minus x squared. So we can have, at the intersecting point, the equation of a curve and the equation of a lines are equal. So we have at x is equals to be 8 minus x squared. So we have, this is of course minus 8x. So this is 8x, we have it here. So we have x minus 8, x is equals to negative x squared. So we have negative 7x is equals to negative x squared. 7x is equals to p. 7x is equals to p x squared. So you can have x squared minus 7x. Of course, this one is equivalent to 0. So you factor out x. This is x minus 7 is equals to 0. So x is equals to 0 or x is equals to 7. You also ignore this x is equals to 0 because the values of p, the point q, the x-axis, q, the values are above 0. So in this case now we use y is equals to the line y is equals to x, but the value of x here, and thus in this case we take 7, so our y is equals to 7. Therefore, the coordinates of q, the coordinates of point q, x is equals to 7, y is equals to 7. So we have the coordinates of p, y is x, so we have 5, 15, and the coordinates of q are, we have 7, 7. Calculate the exact area. Calculate the exact area. Calculate the exact area of a region bounded by the curve and the line y is equals to x. So a region bounded by the curve and the line y is equals to x. So the region bounded by the curve and the y is equals to x. We have the coordinates here. The coordinates here we have 7, 0. So we can have 7 to 0 because the coordinates we have, this is 7, 7. So the limits of integration, we are integrating from 0 to 7. We integrate x squared. We integrate the curve 8 minus x squared. So this one is giving us this is of course 8x, so we have 4x squared because you will be having 8x squared divided by 2 minus x cubed all over 3, and the limits is between 0 to 7. So you substitute when x is equals to 7, so we can have when x is equals to 7. When x is equals to 7, you will have 4 into, this is 7 squared minus 7 raised to power 3 over 3. We subtract when x is equals to 0. So this one is 4 into, we have, this is 0 squared minus 0 cubed all over 3. And if you work out that one, you will get that area. You will get this area as 57, and 1 over 6, in this case, square units. Correct. Now, Roman 2, the area, so find the region, the area of the region bounded by the curve and the line y is equals to 3x. The region bounded by the curve and the area y is equals to the region bounded by the curve and the area y is equivalent to 3x. Simply, in that, what we mean there, it is the area of the curve. This one you get as the area of the curve. It is the area of the curve. You get this one as the area of the curve minus the area below the minus the area of the line. So we have the area. It is the area of the curve minus the area of the area of the curve. The area of the curve minus the area below the line. So minus the area. This is below the line. Below the line, y is equals to 3x. Below the line, y is equals to 3x. So to get the area, the region bounded by the curve, it is the area of the curve. The curve is 8x minus x squared. minus the area below the curve minus the area below the line y is equals to x squared. So simply what you do there, the area, the coordinates we have at this point B, it is 5, 5. So we have these coordinates here. X here is equals to 5. So our limit of integration is from 0 to 5 to get the area of the curve. Y is equals to 8 minus x squared. And the area below the line y is equals to 3x. The area of the line y is equals to 3x is this line. So we are integrating 8x minus x squared from 0 to 5. We subtract the area below the curve. Integration of 3x, a limit 0 to 5. So we can have this is the area with 0. We have this is 0 to 5. The area of the curve, which is 8x minus x squared. You subtract the area below the line. The area below the line is between the integral of 0 to 5. Then we have this one as 3x. So this one is equivalent to what? This one is equivalent to P for x squared minus x cubed all over 3. The limit is between 0 to 5 minus the 3x squared all over 3 all over 2. Here we are dividing by 2, and the limit is between 0 to 5. And the limit is between 0 to 5. The limit is between 0 to 5. And if you calculate that one, you simplify this one on this side. From this side, you will be getting 58. So we have this one as 58 and 1 over 3 minus 37.5. So that area is equals to 20. Then we have 5 all over 6. Then we talk of square units. Then finally, we are supposed to find the area of the shaded region. So the area of the shaded region is the area bounded by the curve and the line y is equals to x. You subtract the area bounded by the curve and the line y is equals to 3x. So this is the area. So to get the area of the shaded region, it is the area bounded by the curve. So you have the area bounded by the curve. So here you have area of bounded by the curve, bounded by the curve, and the line, area bounded by the curve, and the line y is equals to dx minus. So you subtract area, you subtract the area bounded by the curve. So you subtract here area bounded by the curve, area bounded by the curve, area bounded by the curve, and the line y is equals to 3x. So the area bounded by the curve and the line y is equals to x, we have this one as 57. So this one as 57 and 1 over 6. You subtract the area bounded by the curve and the line y is equals to 3x, and that line, the area is 25 over 6. And if you subtract that one, you will get as 36 and 1 over 3 square units. Kindly don't forget to subscribe. You click the notification bell, you get notified once I upload a new video. These kind of questions are set in paper 2, section B. Thank you.